Good evening, all. Am I audible? And is my screen is visible? Can you all hear me, guys? Okay. Good evening, all. Good evening, all. So let's start the session. So last class we have started with the MC internship. So we have started the MC module in the internship, and we have discussed about the project demo and requirements. Okay. So we discussed about a washing machine project, and I have shown you the demo, and also I have listed out the requirements for the project. So in the upcoming classes, we are going to learn about the embedded programming which are required for completing this project. Okay, so this is basically the plan for the MC module. Okay, we first learned about the project requirements, and we have observed the project how it works. And the next is we are going to start with embedded system, introduction to embedded system. So since we are doing embedded system project, so we should understand embedded system. Okay, so that is the second chapter, introduction to embedded system. So then we are going to understand the microcontrollers. Since our project is based on microcontrollers, we have to understand the microcontrollers. That is the third topic. Then we are going to start with embedded programming. So we are going to learn how do we program the microcontroller and also some basic peripheral. Okay. Then at last, once after learning about the basic concepts and peripheral programming, we are going to start with the project implementation. Okay. So project implementation, I'm going to do in the class itself. So you're going to do along with me. Okay. So installation process for PicsimLab and MPLAB. So since we are going to do this internship online, so we are going to simulate the tools only. Okay, we are not going to work on any hardware board. So the simulation tools installation, it is specified in the LMS. Okay, so I'll show you, how to download those uh, tools and how to install it. So this section you can refer slides installation. Okay, so this is going to have slides only. So some documents is there. So for installing the PicsimLab and also the MPLAB XIDE. Okay, and also XE8 compiler. Okay, so basically you have to install three things in your system. Okay, so the first one is MPLAB XIDE. So three things you're going to install: MPLAB, XIDE. So this is for writing program. So this will have editor. Okay, this is an IDE where the editor is supported, and also we can compile the program. Okay, here in the MPLAB XIDE, and we need a compiler. Okay, so we are going to use XE8 compiler. So this you have to install. Okay, this is number one. Number one, number two. Okay, and number three is, so we are going to use simulation tool PicsimLab. Okay, so instead of hardware we are going to simulate the hardware in the tool. So this PicsimLab tool you have to install. So these are the three things to install. Component. Okay, yeah, have to do this installation. Yes, about project how to do, I'll explain at the end. Okay, once we start project implementation, so I'll explain about how we are going to do project, group project. All this I'll explain later. No, weekly test for now it's not scheduled. In case if there is any test schedule, we will inform you in the announcement. Okay. So in LMS, I hope you everyone have got LMS access. Okay, so here under the microcontroller resources, you can download data sheets. Okay, so I would like to, I would ask everyone to download data sheets, both semantics. Okay, and some template codes are also there. So all this, all this documents you can download, okay, which are under this microcontroller resources. Okay, and any announcement no regarding the class or regarding any information, any test or any submissions, we will be posting in the announcement section. There is an announcement section. Yes, int bi no, under this there is an announcement section. So here you can check. In fact, you will get mail also via this LMS. You will get mail. You can check your mail also, okay, regarding any announcements. No, you install after the class, not now. Install after the class. I already have MPLAB XID in my system. Could you please how to? Okay. If you have XC8 and MPLAB ID, you can use the same. And the PicsimLab installation, you can check this installation slides. Okay, slides installation. This document you can check. I'll tell you how to read datasheet. I'll tell you. Yes, yes. So if there is any need to take test or if there is need to submit any program, we will announce that in the LMS. Okay, we will post in LMS. Okay, the recordings, no class recordings in the same course, embedded system internship general is there. Here there is an announcement. In fact, we will add one more row here for queries. Okay, for discussion forum. Okay, it is not available currently. We will add a discussion forum here. So any doubts related to the class or if any errors based on the installation, if you're getting some errors, you can actually post the questions here. So I will be replying. I or either another mentor will be replying for your queries. Okay, so that will be added immediately. After the class, we will add this discussion forum. Okay, so in discussion forum, you can post your questions because in our class it's difficult to check each individual's problem and solve it. No, so you can post your questions or doubts or any errors here in the discussion forum. We will be replying. Okay, over there. And below this no C module recordings, you can see here all this are C module recordings. Okay, and below that I have added MC module recordings. Okay, day one, day two basis I will add. Okay, so for now this test we are not scheduling. We'll tell you when to take this test. And C programming resources are there. Similarly, microcontroller programming resources are there. Okay. So shall we move on to the class? Will inform you any submissions. If we if we are expecting any submissions or if we are expecting you to take any test, we will put it in the announcement. Okay, so let's move on to the class session now. So already we have started with the introduction to embedded system. Okay, so we have completed the first topic, that is project demo and requirements is completed. Okay, uh, you can we can now move on to introduction to embedded system. Okay, so announcements, it's there in under general. You will be able to see here announcements. Okay. Okay, after the class you can install. Okay, after the class you can install, not now. XC8 compile any version, 2.31 or 2.4, you can install any version. Okay, you go with 4. Version 3 is there. Okay, you can go with 2.3 or you can go with 2.4. Anything is fine. Okay. how to install all this. It's there in this LMS. Okay, here the slides are there. No, so you refer the slides installation. Okay. No, no, I'm not going to show tools today. So today we are going to discuss about introduction to embedded system and microcontrollers. So you after the session you download this and keep it ready. Okay, not today. Okay. So for tomorrow's class you download this and keep it ready. So PicsimLab you can install you know 8.9 version you can install, or 8.11 also you can install. Okay, so I think that is the advanced version. You install 8.9. This is a stable version. Okay, you install 8.9 version. Okay, this is a stable any version 8.9. Okay, and MPLAB XAD also you can install 6.35 you can install. Whatever is latest you can install. Okay, yes, you can install 2.5. Okay, so latest version any 6 dot versions. Okay, you can install. So I have 6.6.2. Better you install 6.20. Okay, this is a stable version, so you can install 6.20. Okay, 6.20 version you can install. Okay, if you have already installed, not a problem. Okay, if you're installing, you can install 6.20. Okay, sample app you can install 8.9. This is a stable version. So XE8 you can install 2. Let me check. You can install 2.35, or there is 2.45 also you can install that. Okay. That's okay, Ujjwala. Any version is fine. 22. For Ubuntu also we have installation guide. You can check that. Okay. So I've shared the screen. I hope the screen is visible. Okay. So I can start with the session now. Okay. So for all other queries now, you post your queries in the discussion forum. Okay, we will be replying that. Okay, so now let me start. Okay, so just make a note. These are the to do. Okay, these are the to do list for today. Okay, so this you have to do. So let me start with the class. So introduction to embedded system. So in introduction to embedded system, already we have studied about what is embedded system and examples of embedded system. Okay, so embedded system is nothing but any combination of hardware and software which is to do a specific task, which is intended to do a specific task. So these are the keywords should be there in the embedded system definition. So it's hardware plus software to do a specific task. Okay, so that is an embedded system. Okay. So we have discussed about some examples on embedded systems, some real-time examples. You have given microwave oven, or refrigerator, or washing machine, TV, robotics examples, home automation system, avionics machine, uh, and also rover example, routers. It's an example of embedded system, and all the medical equipments. It's an example of embedded system, and mobile phone. It's an example of embedded system. Okay, so these are the examples of embedded system. So today we will continue with categories. In fact, we were discussing about categories, but we were not able to complete it. So today we will start with categories only. So there are four different categories of embedded system. You can categorize the embedded systems into four categories. Okay, standalone, real-time, networked, and mobile embedded system. So standalone embedded system, it can take decision by its own without any human interference, and it has an intelligent part in it. Okay, for example, the Tesla car we have discussed, a self-driving cars. It's an example of standalone embedded system. So in fact, this is considered as a independent standalone embedded system. Okay, so this is a category called as embedded system. So this is an independent standalone embedded system. Okay, so there is something called as slave standalone embedded system. So in slave standalone, so the embedded system cannot take decision by its own. Okay, cannot take any decision by its own. It doesn't have an intelligent part in it. Okay, it just blindly follow the instructions given by the user. Given by user. Okay, for example, let's consider we have a washing machine, semi-automatic washing machine, the older washing machines. So let's say you want to wash your clothes. Okay, you want to wash your clothes. You have put your clothes and all the detergents you have added, but you didn't add any water. You didn't connect this water inlet pipe. Okay, you're giving an instruction to start the washing machine. Okay, you have given instruction to start the washing machine. Start button you have pressed. Okay, so will this washing machine run or it will not run, or it will throw error? So I'm talking about the older washing machines. Talking about older washing machines, so you have added, you have put your clothes, but there is no water inside it. Will it start or will it not start? Yes, it will run. Yes, it will run. It will definitely run. Correct. Okay, so is there any use of washing clothes? Is there any use of washing clothes without water? I'm talking about older washing machine, not the fully automated washing machines. Not about fully automated washing. In fully automated washing machine, we will get a error. Okay. In older ones, it will start. It will not check whether there is a water available or not. Okay. Since we have given the start option, we have pressed the start button, so it will start running. Okay. So it is blindly following the instruction given by the user. Okay. It is not checking whether there is water or not. Okay, so this is called a standalone embedded system. Okay, it does not have any intelligent part. Okay, washing machine is an example. So, wherein independent standalone embedded system, it can take decision by its own without human interference. It has an intelligent part, like the Tesla car. Okay, so self-driving cars. So if there is construction work going on the path, it will reroute automatically in case there is a red signal. So it will stop on the red signal, wait for the green signal. So it will take decision by its own without asking human beings, without human interference. It will take decisions. That's what it's called as independent standalone embedded system. So this is one category of embedded system. So the next category is network embedded system. So what do you mean by network? What do you mean by network? What do you mean by network? Connection. You can say network means it's network connection, maybe wide connection or wireless connection, interconnection of devices. Yes, exactly. Okay. So network in embedded system means that will be a connection. Okay. So multiple components are connected in network embedded system. None are devices are connected together for performing to perform a specific task. So that is called as network embedded system. Okay. So can you give some example for network embedded system? Okay, those systems which make use of internet that can be connected exactly. Okay, connected to the network. So can you give some example for network embedded system? Involvement of many things are gathering, correct only, correct only. Phone, it's only one device, no? Only one device. ATM machine also, it's only one device, right? Okay, it's connected to network. Okay, it's connected to network. You can see cars, robotics. Okay, Wi-Fi routers. Yes, Wi-Fi. Best example is very simple. Best example is, you know, Wi-Fi based automation system or home automation system. So there will be multiple cameras. Okay, multiple cameras will be that will be integrated, and that is connected to one control unit, and data will be transferred over network. Okay, home automation system or any embedded system, Bluetooth based system or Wi-Fi based system. So there is a connectivity. Okay, system. Okay, home automation system or monitoring system. Okay, so these are the examples of networked embedded system. Okay. Okay, so wherever the internet is involved, Wi-Fi based system you can see, okay, internet based, okay, GP technology. Okay, that's one technology. Okay, whatever you're saying, Wi-Fi, all this are a technology. Okay, so if an embedded system using any of this technology, okay, embedded system is using any of the technology, then you can use IoT examples. You can consider as an example of network embedded system. Okay, so this is the second category. So the third category is real-time embedded system. So real-time embedded system, the deadline is strictly followed. The time strictly followed. Okay. So the embedded system are designed to take action within specified amount of time. These are embedded system which are designed to take action or decision within specific amount of time. So in case of there is delay in taking action or decision, it may damage the embedded system. It may be a human life loss or it can be a property loss. Okay. So if the system, it's time bound system. Okay. So time is very strictly followed. It's time bound system. We can also say it's a time bound system. So in case of the embedded system is not able to respond immediately within the specific amount of time, so there may be a loss of property or human life. Okay, so can you give some example of real-time embedded system? ECG, good, good. CCTV, okay, I can consider that as CCTV network embedded system. You can say server lines, cameras, airbags in car. Yes, that's a very good example. I can take this airbags. Okay, so airbags in car. Okay, so let's say we have an airbags, there is an accident. Okay, so the airbags has to open immediately within specific amount of time. Okay, the airbags has to open immediately. Okay, so if the airbags are not opened immediately, car airbags, if it is not opened immediately, then it's a life loss only, right? Life loss. The driver may anything may happen to the driver, okay, or also the passengers in the car. Correct? Yes. BP monitoring system. Okay, you can consider that also. Pacemakers in hospital gadgets, basically the medical applications. Okay, which are developed. Okay, so which has to take decision immediately, right? Or immediately or within specified amount of time. In short span, it has to take the decision or action. So you can also consider pacemaker if it is not taking decision or if it is not taking action within specified amount of time. It's human life loss. Okay, it's a very human life risk only. Okay, so this is a real-time embedded system. In fact, the real-time embedded system, no, yes, flight control system, very good. Flight control system. Okay, fire alarms, good. Okay, yes. So in fact, this real-time embedded system, it's categorized into three types. Okay. So calculator, it's not a real-time embedded system. Okay. So if the calculation is wrong, is there anyone going to affect because of that? Is anyone going to die because of that? No, it's not going to affect anyone. Okay. Even microwave oven also, if food is not cooked properly, no one is going to be affected, right? Yes, time oriented, correct. I'll tell you the categories. There are three categories of real time embedded systems. So, one is hard real time. Okay, hard real time. So, where the deadline is very strictly followed. Okay, deadline is strictly followed. Okay, so if something happens, you know, something happens if the embedded system is not able to take decision within specific amount of time, it's a life loss. Okay, so human life loss. So all the medical applications is coming under this category of hard real time only. Okay, so there is airbags, pacemakers. No, it is coming under the category of hard real time embedded system. Okay, so this is first category of real-time embedded system. So real-time embedded system, it's further classified into hard real-time. Second category is firm real-time. So firm real-time. So here also the deadline is very strictly followed. So this is very similar to hard real-time. Okay. So but if the embedded system is not taking decision within specified amount of time, so this is property loss. Okay. Property loss, not the human life loss. Okay, it's not a human life loss. Someone told no fire alarms. Fire alarms you can consider. Okay, so fire alarms if if that alarms is fixed in a manufacturing industry, let's say it's a godown, it's a, garments godowns. Okay, so if that alarms doesn't work, okay, then it is completely property loss. Okay, so whatever stock it is available in the garments, that will be burnt, right? So that is example of in, let's say, garments. So that is an example of firm real time. Okay, so in case if there is a person inside that, then it is becomes hard real time. Okay, so in case if there is a employees or workers inside the garments in the godown, then it's a hard real time. Okay, so if there is a life loss, then that becomes hard real time. If it is a property loss, then that is a firm real time. Okay. So another example, we can consider this missile examples, this rovers. Okay. So rovers, when we launch from Earth to Moon, okay, Earth to other planets. So there is no scientist. There is no scientist on the rover. Okay. So just a device. So in case if it is a crash land, okay. So whatever investment we have done on this rover, it's a loss only. Okay, so it's a huge investment, right? So that's a loss. Okay. So that is in that case also the embedded system needs to take decision or action within specific amount of time. If it doesn't work properly, then it's a crash landing and it's a property loss. So this is firm real time, and there is something called a soft real time. Okay, soft real time. So we can just tolerate some amount of delay can be tolerated. Okay, so soft real time also it's time bound system only, but can accept delays. Okay, can accept some amount of delay. So here only you can consider this microwave oven or washing machine. So let's say washing machine, you are using washing machine. So the washing machine, let's say it says initially it says 40 minutes to wash the cloth. Okay, but it is taking some extra time. It's taking 15 minutes to wash. Will there be any problem? Will there be any problem? Is there any life loss or property loss in this case? Is there any property loss? Or you consider Google cars itself. Okay, when you enter the destination. Okay, so it will tell you 1 hour to reach, 1 hour to reach. But due to some traffic or due to some rerouting, okay, so the Google has took the travel has took 1 hour 15 minutes. So will there be any problem? Will there be any problem? Is no one is anyone is going to affect because of that? No, anyone is life is going to be affected because of this? No, it's not a problem. So this is called a soft real time. Okay. Yes. Missile example you can consider as a firm real time. Okay. So the property is lost. Okay. The property is lost. So rover you can consider as an example of firm real time. In case along with the rover there is a scientist also. So then that is coming under hard real time. If there is no human beings then involved, then that is firm real time. If there is a human being, then it is hard real time. Okay. So these are the categories of real-time embedded system: hard real-time, firm real-time, soft real-time. Can accept some amount of delay, can tolerate or accept some amount of delay. So this is also time-bound system, but can accept some amount of delay. So this is the third category of embedded system, and the last category it is mobile embedded system. So what does mobile means? What do you mean by mobile? What do you mean by mobile? Movable, yes. So movable we can call as mobile. Okay. So any embedded system, if it is movable, then it is coming under the category of mobile embedded system. Okay. So you can consider this cell phone. Okay, the mobile phone. It's a movable. It's a movable or portable. Okay, any embedded system which we can move or move from one place to other place, then that is coming under the category of mobile embedded system. You can say mobile smartwatch. Very good. Okay, smartwatch. So it's a mobile embedded system. Okay. And operator and battery power. Correct, correct, Varsha. CCTV and TV is which is fixed. We are not moving it, right? TV, televisions, it is fixed. We are not moving it, right? It's not portable. Once if it fixed in one particular place, we will not move that. Okay. So any embedded system which is portable or movable, that is considered as a mobile embedded system. Okay. So you can consider smartwatch or mobile phone. You can consider. Okay. So laptop, understand, laptop it is not an embedded system at all. Laptop or computer, okay, so please remember laptop or computer. So that is not an embedded system. That is general purpose system because so laptop it has hardware and software, but it is not for a specific task. It is not for a specific task. It is for general task, generic task. Okay, generic task. So that's why it is general purpose system, not embedded system. So just be clear with this. Okay. Cleaner robot. Okay. So laptop it's not an embedded system. So any fitness tracker, the watch. Okay. You can say robots. You can say robot. Drones. Okay, drones. Yes, earbuds. Okay, fitness bands. Okay, good. Robotic arms. Okay, okay. So camera is fixed. No. Okay, you're saying digital. Yes, digital cameras. It's portable. A security system. We will be having cameras. That is fixed in securities. Home automation system or monitoring any control system. So that we will have security cameras. That is fixed. So that's not movable. Okay. So these are the main categories: standalone, real-time network, and mobile embedded system. And apart from these four categories, there is something called as hybrid. Okay, so hybrid means if embedded system, if it is coming under more than one category, okay, more than one category, then you can call it as an hybrid embedded system. Okay, so because if any embedded system, if you take, even if you take smartwatch, so this is connected to the internet, right? So this is also coming under the category of network. Okay, and if you take this robots are movable. Okay, you can take robots. So this is an intelligent, okay, this is an intelligent device which is coming under the standalone category, and also it's connected. Okay, network, the embedded system also it's coming under, and it has to take a decision, real time based. Okay, so real time, within specific amount of time it has to take some decision, so it is coming under network, real time embedded systems also. And it's mobile, so it is coming under mobile embedded system also. If you consider robots, you can consider the self driving cars. Okay, so Tesla cars, it's actually coming under all uh, category. Okay, it is falling under all the categories. Okay, so nowadays if you take any embedded systems, it will be falling more than one category. Okay, so that is called as hybrid embedded system. Okay, so we discussed about standalone, real time standalone. We have slave standalone and independent standalone embedded system. Slave standalone does not have an intelligent part in it, so it will blindly follow the instructions given by the user. And independent standalone embedded systems, it can take decision by its own. Okay. And real-time embedded system, it's time-bound system. So we have three categories in this. Networked embedded system, where whenever the device is connected, we can say it's a networked embedded system. And mobile means any embedded system which is movable or portable. Then you can see mobile embedded system. So robots, it's coming under all the categories. Okay, if any embedded system, if it is coming under more than one category, you can call it as a hybrid embedded system. Okay, so we have discussed about hard real time, firm real time, and soft real time. So hard real time should meet its deadline, okay, within specific amount of time. So this is deployed in life critical applications. Firm real time similar to hard real time, but properties. If the embedded system is not taking decision, properties last. Then soft real time can have tolerance in meeting its deadline. So you can consider washing machine or this purpose. No, mobile phone, it is not a general purpose. This is an embedded system only. Okay, so even though the mobile phone, okay, it is doing a lot of tasks, it is still under the category of embedded system only. Even the last class example we have seen, mobile phone, it's coming under the category of embedded system only. Because can you prefer mobile phone for developing an application? Let's say you want to develop an embedded system. Will you choose mobile phone? Yeah, I agree, Manisai Raju. So some mobile phones, we have facility for writing the program. Even some advanced mobile phones, Apple iPhones, we have inbuilt compiler itself. But will you prefer? You have a laptop and you have a mobile phone. Which one will you prefer? You have a laptop and mobile phone. Which one will you prefer for developing an embedded system? Will you prefer mobile phone or laptop? Mobile phone, it's an embedded system only. Mobile phone, it's an embedded system only. Okay, so we will definitely not prefer mobile phones for developing an application. We will prefer laptop. We will prefer laptop only. Okay, computer only we will prefer. Okay, so that's why mobile phone, even though it is doing a lot of task, it is coming under category of embedded systems because we will not prefer mobile phone for embedded system development or any application development. We will not prefer mobile phone. We will prefer laptop or the personal desktops only. Okay, so this is about categories. So next, let's move on to the components of embedded system. Okay. So when we have an embedded system, so can you list out the components in embedded system, or can you tell me the very important component in every embedded system, not specific to one particular embedded system? I'm not talking about one particular embedded system or one category. So in general, if you take any embedded system, so what is a very important component, or what component will be present in the embedded system, in every embedded system? What is the important component present in every embedded system? Microcontroller, good. Microcontroller or microprocessor, very good. So microcontroller, it can be, or microprocessor, it can be, or it can be SOC. So that is very important component present in every embedded system. So it can be a microcontroller, or it can be a microprocessor, or it can be SOC. Okay. So I'll tell you the difference between all the three. What all microcontroller, what is microprocessor, what is SOC. I will explain later. Okay, so when you develop any embedded system, so it is hardware plus software. Software means there should be some code, right? So we should write some code and we should control some peripherals, right? So that code, where are we going to run? On microcontroller or microprocessor. So we need, to run a code, we need a processor basically, right? We need a processing unit. So that is the core component, okay? So microcontroller or microprocessor SOC is the heart of the embedded system, okay? It is a heart of the embedded system. So that should be present. So what is the next, very next component? Okay, microcontroller, or it can be microprocessor or SOC. What is the very next component? Next important component. Yes, I agree, Anusham. Sensors, actuators will be there. Okay, okay, correct. Interrupt timers. Okay. Any other component? Okay. The second most important component. I told this is, heart. What is the brain? So processing unit is the heart of the embedded system. So what is the brain of the embedded system? Very next important component. Memories. We can say it's memories. Correct? Good, Shiva. Memories. Memories, it's the next important component in every embedded system. Okay, so that's like a brain of the embedded system. Okay, so there are basically different types of memories. Memories in embedded system. So there are two main categories of memory. So one is RAM memory, second is ROM memory. Okay, so what does RAM stands for? So it's random access memory. So whereas ROM stands for read only memory. Okay. So RAM memory static. So RAM memory only it's classified as static RAM and dynamic RAM. Correct way, no? Okay. So RAM memory basically it's volatile memory. It is a volatile memory. What do you mean by volatile? What do you mean by volatile memory? So data is available until the power exists. Okay, if there is no power, then the data is lost. Okay, so this is RAM. And RAM we can just do read and write operation. Okay, so we can write data to the memory and we can read from the memory at any number of times. So n times you can read. Okay, n times you can read, n times you can write. Okay, so whereas ROM memory, so you can understand from the name itself, it's read only memory. So which means we can only do read operation. Okay, so you can write once and read n times. Okay, you can read n number of times from the memory. Okay, so yes, this is a category of non-volatile. So this is non-volatile memory. Okay, so even if there is no power, data is available. Data is permanent. You can see the data is permanent. Data is available even if there is no power. So this is ROM memory. Okay, and also we have categories for RAM and ROM. So SRAM and DRAM are the categories of RAM memory. So SRAM stands for static random access memory and DRAM stands for dynamic RAM. Okay. So static RAM, no. So this is low power consumption comparing with the dynamic RAM. So dynamic consumes more power. Okay. So do you know where the static RAM and dynamic RAM is used? Yeah, ROM category is correct. Okay. So can you tell me where the static RAM and dynamic RAM is used? No refreshment needed, correct. faster, more expensive. Okay, correct, Varsha. Yes, cache memory, correct. So static RAM is used in cache memory since it is faster. Okay, so it's low power consumption, it is faster. So because of this properties, okay, low power consumption and faster. So because of this property, it is actually used in cache memory. So cache memory is static RAM. Okay, and dynamic RAM. So it consumes more power. Okay, so it is actually used as main memory in computer. Okay, this is used. And under the category of ROM, so ROM also it has different categories. So ROM memory we have PROM, which is programmable read-only memory. So this is programmable only once. Okay, so it is programmable, but only once we can program and read n number of times. Okay, so this is also called as OTP. This type of memory it is also called as OTP. It's not one-time password. Okay, it's one-time programmable. Okay. So since it is one-time programmable, only once we can program. Okay. So this type of memories can be found in toys industries. Okay, kids toys, the kids, uh, the remote cars, or you can consider, the kid small cell phones. Okay, small phones where if you press the numbers, for every number there will be respective rhymes will be playing, right? Our kids cars also, so there will be some buttons. If the buttons are pressed, some rhymes will be playing, right? So that is programmed only once. Okay, so we cannot change, we cannot reprogram, so that's where this kids toys industry, toys manufacturing industry, this PROM is used. And also you can consider a washing machine. So washing machine, are you changing the programs? Are you changing those programs? Let's say for spin 12 minutes, it's set means is it possible to change that to 30 minutes spin timing? And you change the programs and all. Are you upgrading this software in the washing machine? No, you're not doing it, right? So that is coming under the category of PROM. So only once we are programming. Okay, so this is the first category. And second category is EPROM. So EPROM means it's erasable programmable memory. So erasable programmable read-only memory. So this is erasable. We can write the program, but we can erase. But how do we erase? By passing UV rays. So we have to pass UV rays to erase the program. Okay, that's why it is also called as UV room. Okay. So since it is erasable only using UV rooms, so this we are not giving to customer. Okay, this we are not giving to customer, because if let's say you are using this, let's say you are using mobile phone. So in your mobile phone you have this EP room. Okay, you have taken selfie. So the selfie is not good. You want to delete it. Are you going to pass UV rays to delete? Is it possible? Do you have this UV rays at your home? Is it possible to delete a photo? Or are you going to take where this UV rays will be available? It's going to be available in the laboratories only, labs only, right? So it's not possible to bring our phone to labs every time when you want to delete. Okay, so if you want to delete some photos, or if you want to delete some number, it's not possible for us to pass UV rays. Okay, so that's why this is not used at the customer applications. Okay, in the product we are not using this EP room. Okay, so it is actually used in labs only, laboratories for R&D purpose. For R&D purpose, only this EP room is used. Okay, so next category is M room, or you can consider it as a maskable room. Maskable read-only memory. So what do you mean by mask? What do you mean by mask? Yeah, correct. But yeah, it's there, it's there. That is different category, I'll tell you. That is WP room. That's different category. What do you mean by mask? Mask means what? What do you mean by mask? No idea. Protected, hide, covering, good. Programmed during manufacturing, exactly. Hide, you can say hide our product. Okay, so this type of ROM, it is used to protect or cover or hide some information. Okay, so let's say you have a memory, so some amount of memory, some bytes of memory will be protected. Okay, so this will be having very important details. Let's say for example manufacturing details, the date when the IC is manufactured, or the slot number, IC number. So these numbers user should not modify. Okay, so during the time of manufacturing that particular IC itself, that memory will be masked or covered. Okay, so that no one can modify that. So this, that there will be some informations written over here, written only once, but cannot be rewritten again and again. Okay, so some amount of some bytes of memory is masked. Okay, so that is called as maskable read-only memory. For example, manufacturing details can be IC details can be hidden, or it can be covered. Okay, so anyone can read it, but they cannot modify. So these are the different categories of ROM: PROM, EPROM, MROM. Any questions? Yes, calculator, it's an example of, you can consider PROM, programmable only once. Barbie phone characteristics, that is a very good example of PROM. Encapsulation. Oh, okay. Hiding only. Data is hidden. Okay, in hardware, data is hidden. Okay. So apart from this, ROM, RAM. Okay, so ROM and RAM, it's main category. So apart from this ROM and RAM, we have another category. We have another category. So that is hybrid. Hybrid memory. So can you guess what is hybrid memory? Third category is, can you guess what is hybrid memory? MROM, one second. So MROM means maskable ROM. Okay. So mask means we can say it's hide product. Okay. So if manufacturer decides to hide some information from the user, okay, so they can write it in the mask ROM. Okay, so for example, the manufacturing details the user should not modify. They can read. They should not modify. Okay, so those type of memories used to write this manufacturing details or IC numbers, that is under mask ROM only. Okay, yeah, yeah, sure. I'll provide. Wait. I'll complete this hybrid memory. It stores extra data. No, hybrid memory, it is having the property of both ROM and RAM. Okay, so we have correct Kavita, correct Bhavna, combination of ROM and RAM. Correct Jivita. So it's combination of ROM and ROM. So it has properties of uh, hybrid memory. It has properties of both ROM and RAM. Why do we need these properties of both ROM and RAM? So I'll take this mobile phone example itself. Listen carefully. I'll take this mobile phone. So let's say mobile phone. You are using a mobile phone. You are taking selfie. Okay. So let's say the selfie, the photo, it's stored in RAM memory. Let's consider it as static RAM. It is stored in the RAM memory. Okay. So the selfie is good. Okay. Selfie is good. So you want to keep the photo. Okay. But what happens is soon after taking photo, your battery is low. You're getting a battery low warning, and immediately in 2 3 minutes, the phone got switched off. Switched off. Okay, so you are charging the mobile phone. It is charging. You're charging, and you are restarting the mobile phone. Okay, charge and restart. Okay, so will you be able to find the photo in your mobile phone? Will it be available? Will it be available? So the photo is stored in SRAM. Okay, phone got switched off. You're recharging and restarting the phone. The photo, will it be available in the memory? No, definitely not. It will be erased because when there is no power, the data is lost. Okay, there is no power, the data is lost. Data is lost. Okay, so in this case, we cannot go with RAM. So let's say I'm using ROM. Okay, I'll take PROM. Okay, so the selfie is stored in this PROM. Consider in mobile phone, I have PROM. Okay, so this time the photo is not good. I need to dull it. Is it possible to dull it? Is it possible to dull it? Is it possible to delete the photo when it is stored in PROM? Delete and retake another photo? No, it's not possible. It's not possible. You can write once and we can read. Okay, it's read only. It's read only. You cannot modify this. Okay, and it's not possible. Not possible. So in this scenario, we need a type of memory. Okay, so to retain our data, and also if it is not good, we should be able to rewrite. So that is when we need the property of both ROM and RAM memory. Okay, so that's when we need doubly that is hybrid memory. So hybrid memory, we have the categories double EPROM. Okay, that's when we need hybrid memory. If you want the properties of both ROM and RAM, we have to go with double EPROM. Okay, so this is electrically erasable, programmable, read-only memory. So it's erasable by electrically. Okay, by passing some signals, we can erase. Okay, So this is coming under the category of hybrid. And we also have flash memory. So flash memory, it is also a hybrid memory only. Okay, so EEPROM, it is basically byte accessible, which means you can write 1 byte, you can read 1 byte. Okay, so every operation you do with memory, it's only one byte accessible. Okay, so it suitable for storing small amount of data. You can read or write. Okay, it has both read or write property, and also it is non-volatile. Data will be persistent memory. Okay, so this is suitable for storing small amount of data. Okay, so this is, for example, you can store a password. Okay, if you have a device, let's say password or protected locker is there, password based locker is there, so that to in that embedded system to store password, this memory can be used, EEPROM is used. Okay, and under flash memory we have two categories, NOR flash and NAND flash. So NOR flash and NAND flash, so this is block accessible. So which means when you write some data into the memory, okay, you can write blockwise. Okay, it is block accessible, which means one block can be n number of bytes. One block equal to 4 bytes or 8 bytes or 16 bytes or 32 bytes or 128 byte. Okay, it can go up to 56 bytes also. Okay, so this is block accessible. So you can store large amount of data. So this type of memories can be used in pen drives, pen drive, we to store some movies. Okay, large amount of data, no, so that is can be used, that's where it can be used. And NOR flash, it's I'd say it is suitable for data storage. Okay, large amount of data. Okay, so NOR flash, it is suitable for storing code storage. Okay, because it is more reliable, so you can store code in it. And also it has something called as XIP support. Okay, so which is used to execute, it is to use to execute code. Okay, same like RAM, the code will be executed, no, same like that. In flash memory also the code can be executed. So because of this is used in microcontrollers. So this is hybrid memory. Okay, both EEPROM and flash memory, it's coming under the category of hybrid memory. Okay, Sakya. So you can note down this or you can take a screenshot of this. Quickly, you can take a screenshot of this. Zoom in, okay. You can note down this. Wait. You can note down this. I'm just waiting. Some of them are asking for 2 minutes break. No short break. Okay. Meanwhile, you can note down this, or you can take a screenshot. I can scroll up also. You can check this as well. Okay. Blood. Is that okay now? Is it still blood or is it clear? Okay. Yeah, Krishi, you can relate with this. Okay, you can relate with this MROM. Okay, but actually, how this is used is to hide the manufacturing details in an IC. Okay, so we are just talking about memories in embedded system, right? Memories in embedded system. That's why. Yes, I will be uploading these notes. I will be uploading the notes, not a daily basis. Okay, weekly basis. I will be uploading. Or end of this internship, I'll upload in LMS. Shall we proceed? Yes, you can watch a recorded session, Silango. That's there in LMS. You can find that. You can watch recorded sessions. Shall we proceed? So coming back to the guys, please listen. Please listen for a moment. So I'm going to continue. So the components we are discussing about the components of embedded system. So we discussed about different types of memory, and apart from this, so as most of you have mentioned, the sensors, it is also an important component. Okay, so the next important component we can say is sensors. So sensors can be any type of sensors, maybe temperature sensor, a humidity sensor, or IR sensor. Okay, it can be any type of sensor. So the sensor output can be an analog or a digital. Am I audible now? Not audible? Can you hear me? Is my screen visible? Fine, right? Can I proceed? Okay, sorry, there was some technical issues. Okay, let me proceed. Okay, so sensors are a component of embedded system. So sensors are input to the microcontroller. So microcontroller process the sensor input and it gives output. Okay, so actuators are nothing but the output devices only. Okay, so maybe motor or speaker. Okay, you can consider that as an actuators. Okay, so actuators it needs a voltage level to operate. Okay, shall I continue? Yes. Okay, so actuators need voltage levels to operate, but microcontrollers or microprocessors it gives output in terms of digital only. So to convert that digital to analog, DACs are required. So that is also a component, important component in an embedded system. Okay. So next is human interfaces. So human interfaces may be an LED, or it can be a switches, or it can be a, display, LCD display. Okay, so this is all human interfaces. Okay, so in an embedded system, so that may be an LED or a switch, or can be both, or can be displays. Okay, so these are human interfaces. So this is also a component in embedded system. So next we may have application specific ICs, FPGA, field programmable gate array, or application specific ICs will be there in embedded system. Apart from this, all this maybe let's say you have an RTC, it's a real time clock. You can have that in an embedded system. Okay. Or you can have a timer, external timer. So that is also a component in embedded system. So next is a diagnostic port. So what do you mean by diagnosing? Diagnosing. What is meant by diagnosis? What do you mean by diagnostic? Diagnosing the problem. If there is a problem in an embedded system, so we need to debug. Okay, so debug. We need to analyze what is the problem and we need to fix that. Okay, so for that purpose, there can be a port in embedded system. So that is a diagnostic port. Okay, so this is all hardwares. Okay, so this is all hardwares and that can be part of a board. Okay, so Can you hear me now? Am I audible? Can you hear me? Shall we proceed? Okay. So I'll just recall these components. So the most important component is microcontroller. Can you hear me, guys? Can you hear me now? Right? We can proceed, right? Okay. So along with this hardware, we will be having the software. Okay. So software it is also a component in embedded system. So these are the different components in embedded system. Okay. So hardware plus software it's an embedded system. Okay. So that's it about the components of embedded system. So if you have any questions, you can ask. So we have discussed about what is embedded system. So the examples of embedded system and categories of different categories of embedded systems. So now we have completed the components. Yeah. So components, the main component is microcontroller, microprocessor or SoC, and the next main component, second main component is memory. So memory, it's like a brain of an embedded system. Okay, and we will be having ADC, DAC, so to convert analog to digital and digital to analog. Okay, and sensors as another component, and actuators. So actuators are devices which are used to convert electrical energy to mechanical energy. Maybe for example, motor or a speaker. That is an actuators will be a part of embedded system. Okay, so human interfaces like LED or LCD or digital keypad switches or matrix keypad switches, all those are component of embedded system. And we will be having a diagnostic port for debugging the board, that is also an embedded system. And application specific, okay, application specific ICs will be there. Yes, communication port, communication specific ICs also will be there, a part of embedded system. So that is, general mentioned as a ASIC, ASIC, application specific IC. Okay. Memory can be used to store data or also used to store programs. So we have discussed about different types of memory, right? Okay, so memory can be of any type. Okay, so if you take double EEPROM, a small amount of data can be stored. If you take flash memory, okay, large amount of data can be stored. Okay, and code storage we have NOR flash. Okay, because that is more reliable. Okay, so different. It can be any type of memory. Okay, so based on the requirement, the memories will be used.